Hey folks, in this video we're going to look at the energy conversion from kilowatt hours to joules. Now you may remember we talked about this in an earlier video, but I actually just want to run through its calculations, show you how the unit conversion works. So here we have a situation where we're given that a monthly electric bill is 64,000 kilowatt hours. This is actually very similar to a bill that we received at my house recently. So that's what we're given. And again, that's what kWh represents, is kilowatt hours. And what I would like to do is convert that, because that represents the energy consumption for an entire month. I want to convert that to our SI unit of energy, which is joules. All right, so that's what we're trying to get. So what's the equation we're going to use here for this? Well, we need to know what a kilowatt hour is. And that's basically what we're talking about. And of course, we can use our good old friend Wolfram Alpha to do this for us. And in fact, in an earlier video, I showed you Wolfram Alpha doing that conversion of kilowatt hours to joules. But I'm going to show you here where that comes from. So we need to know what a kilowatt hour is. Well, so first of all, we know that a kilowatt is equal to 1,000 watts, which is equal to, the definition of a watt is a unit of power, right? And power is energy per time. So that's 1,000 joules per second. So again, power represents a rate of energy usage. In this case, in order to get the energy actually used, you need to multiply that by a particular time. So a kilowatt hour is equal to 1,000 joules per second times 1 hour, and 1 hour has 3,600 seconds. So there's our energy conversion, similar to the dimensional analysis problems that we did earlier in one of the earlier modules. And again, this is not a class where I'm emphasizing this kind of thing, but I just want to show you what this really means rather than just looking it up. So, and of course, what we're going to note here, if we look at the units, when we multiply all of this through, we're going to get units of joules because the seconds cancel, the hours cancel, the seconds cancel, so we're left with nothing but joules in our final answer. So we just multiply all of that through, and we're going to get 3.6 times 10 to the 6th, or 3.6 million joules, or that's what we call a megajoule. A megajoule is 1,000,000 joules. That's what we got. All right, so that's 1 kilowatt hour. So if we want to figure out how much energy we consumed in that month, then we just need to multiply that through. So we're going to do 3.6 megajoules, and we'll just use megajoules here to make our life easier, and multiply that by 64,000. And we'll just go ahead and do this dimensional analysis here, because 1 kilowatt hour is 3.6 millijoules, so we multiply it by 64,000 kilowatt hours, and again, they cancel out. So we're going to be left with an answer in megajoules. And of course, we can use our old friend Wolfram Alpha for this, or we could just break out a calculator. It's not a difficult calculation. So what we're going to do is I'm going to switch over here to Wolfram Alpha real fast, and we'll do that multiplication. So here we go. We're just going to go ahead and type in the 3.6. I'm going to go ahead and type this times 64,000. And here's our answer. What we get is, you can see here, 2.304 times 10 to the 11th joules, or that's actually 230.4 gigajoules. All right, a gigajoule is a billion joules, or 10 to the ninth. So that's what we've got here for this answer. All right, so here we are. It's 2.304 times 10 to the 11th joules, which, again, that's remembering that a megajoule is a million joules. Or we have a new unit here that we haven't really talked about, 230.4 gigajoules. Where a gigajoule is 10 to the ninth, or 1 billion joules. That's what, again, the prefix giga means 1 billion, 10 to the ninth. So there we have it. That is the energy consumption, total energy consumption for 1 month in joules. As always, ask questions.